That is different modes of data transmission, or you can also call this as a data flow, right? See how the data are flow in the network between the devices that we are going to discuss in this topic. Okay, so the first method is simplex. Okay, so there are three methods followed for the data flow. The first one is simplex, next one half duplex, and the third one is full duplex. So these are the three data flow methods followed. Let's start with the first one, that is simplex. So simplex mode, you can say simplex mode of communication. Here, as you can see in the slide, the message is transferred from the sender to the receiver, right? So let me take the pen. Yeah. See, as you can see in this example, this sender and receiver is there, between which a transmission link is established. Okay, so when a data is sent from sender to receiver here, it happens only in unidirectional. Only one direction of data transfer is possible. Okay, so if one, the sender sends the message and receiver will receive it. This is what happens in simplex mode. Okay, so the best example for this simplex mode is keyboard. See, keyboard, see when you press a letter or any character or any keys in the keyboard, that will be transmitted to the system, right? So that is simplex mode. Or you can see another example is traditional monitors. Like what the monitors will do, it will just display the output on the monitor, right? So these are the two examples I can say for the simplex mode. So what is simplex mode? It is a form of data flow where the communication is unidirectional. So only in one direction the data can be transferred between sender and the receiver. Okay. So the next method, we'll move to the next one, that is half duplex. So as you can see in this slide, let me see, message is transmitted from sender to receiver, right? And receiver also sends the message to the sender. So here this says that each device, say sender and receiver, both can transmit and receive. That is the thing you need to remember here. So between the devices, sending and receiving can happen, but not at the same time. You should remember this. When sender sends the message, the receiver has to receive it. Okay. So then after receiving the data, then the other device can send the data to other device. So that is the way how it works. Okay. So at a given point of time, only either the system can send the data or receive the data. Okay. So best example for this kind of data flow is walkie-talkies. See where police department, they use walkie-talkie, right? Once they send the message, say head of the police department, if he sends a message, that will be received to a particular police officer, and once he copies that, then he can reply to the message to head of the department, right? So that is how it should happen if we use half duplex. And next method is full duplex. See, you can see here, the message is sent between sender and receiver. See, at the same time, the sender can send the message as well as receiver can send the message. So either way is possible in this method. Sender and the receiver who are connected with the transmission link, the sender can send the message to the receiver. At the same time, the receiver can send the message to the sender. Okay, but this is not the case in previous method, that is half duplex. So best example for this full duplex is a telephone network. See, I'm talking to you you can talk back at the same time, right? So this is an best example for full duplex. See, when there is a full duplex, this whatever the transmission link is provided between the sender and this receiver, this channel will be shared between sender and the receiver. Okay. See, because at the same time, sender can send the data to the receiver. At the same time, the receiver can send the data to the sender. So whatever the link that is provided between sender and the receiver, the capacity will be shared between sender as well as receiver. Okay. So that is all about full duplex. So what are the three different types of data flow followed in data communication? Yes?
Ma'am, simplex, half duplex, and full duplex.
Yes, correct. So I can hear answer from only one student, but in the class there are 51 students. So please answer to my question. Anyone else? What are the different data flow followed in data communication?
Um,
Yes?
simplex,
Huh.
half
Yes,
duplex,
simplex.
full duplex,
Second time?
half duplex.
Oh, yeah. Okay, okay. So three types of data flows, simplex, half duplex and full duplex. Example for simplexes, it can be keyboard or monitor. And example for half duplexes, walkie-talkies. And example for full duplexes, telephone network. Okay, these are the three types of data flow. Next, we'll move on to the next topic, that is network. So what is the network? See, in day-to-day life, we use network, right? So our day starts with internet, ends with internet, right? When we woke up in the morning, first we'll check out the WhatsApp messages, or you will check out messages in social media, whatever you have got it, right? And before you go to bed, again you will check the messages. That means my point is your day starts with internet and ends with internet, right? So now tell me, what is this network? Anyone? What is a network? See, you can see here the image that is in the slide. So anyone, what is a network? What is the network here? Can you see at the center? Network is written. So looking at this image, you can define network. Anyone?
Which connects every aspect of the society, ma'am.
Yes, connects everything. Any other definition for network? See, if you look at this image, okay, you can find many devices here, right? Yes or no? See, you can find this as one device, this is one device, and this is one more device, and this is one more device, this is one more. And all these devices are connected, isn't it? Yes or no? Am I audible? Yes?
Yes, ma'am.
Yeah, just tell me, see, all these devices are connected, right? So after connecting, what happens? You can share the data, you can exchange the data, right? The communication happens with between all the devices which are connected to each other. So in general, you can say this as a network. So network is a set of devices connected through the communication links. That is what the definition is all about. See, if you look at the image, you see there are set of devices, right? This is one device, this is one device, this is one device. These are all connected through the communication links. You can see here the links, that is between this and this, there is a link here. So this all together, we call it as a network. See, I'm connected to your device, yes or no? I'm connected to all 51 students in this class. So how? See, I act as a device, or I can act as a node. You can act as a node or a device. I established a link with you so that I can communicate, right? So this all together we call it as a network. So when I say a node or a device, then node can be a computer, or it can be a printer, or it can be your cell phone, or station, or it can be a router that we find in the network. So anything. So any device that can that capable of sending and receiving the data, then we, okay, it can be a computer, it can be a printer, but the device must be capable of sending and receiving the data that is generated by other nodes on the network. So this is all about the networks. So network is nothing but set of devices connected through communication link. So when I say devices are nodes, you must know that what are these devices are. The example for this, computer, maybe laptop, maybe router, okay, maybe modem that you use it at your home. Any such devices which are capable of sending and receiving the data over the network are called as nodes or the devices. I hope I'm clear to you. Okay. Next, with this background idea of network, we'll see the next topic under this network, that is criteria. So if you choose any network, it should obey all these criteria. There are three criteria with respect to network. That is, first one is performance, second one is performance, second one is reliability, and third one is security. We'll see one by one. The first criteria is performance. Sorry, I lost the connection. Yeah, tell me, what is performance? See, some kind of answer I'm expecting from you. Please do answer me. Or are you able to follow? I mean, are you all following whatever I'm explaining here? Am I audible?
Yes, ma'am.
If you have any problem, just tell me, no, so that I can correct myself and continue with the class. Okay, tell me, what is performance? Anyone? See, I say so and so student in your class, his or her performance is good. So based on what I can decide your performance? Anyone? Yes?
Marks, ma'am.
Marks. Okay, based on the marks, I can decide your performance, right? So in the same way here, based on the performance of the network, you can decide whether to choose that network or not. Okay, so this performance of the network can be measured in many ways. The first one is transit time, and the second one is response time. Transit time and the response time. Transit time is nothing but the amount of time required for a message to travel from one device to another. So what is transit time? It is the amount of time that is required for a message to travel from one device to another. And the response time is the elapsed time between an inquiry and the response is called as response time. So altogether, considering transmit time and the response time, you can decide the performance of a network. So see, if I'm communicating with you, then I'm sending a data to your device, right? So the time taken for this transfer of data should be a less one. It should not take much time to deliver my data to the intended user. So that is one factor. And the second factor is the response time. Once the message is reached, then there should be a response from your end, right? So that we call it as a response time. So this altogether decides the performance of network. See, if I consider this communication, that is the lecture, whatever I'm giving to you, the transfer of transit time is very less. I mean, the message, whatever I'm trying to send, it is reaching you at a proper time. But the response time, that is whatever I'm expecting from you, it is taking too much, right? So I can say the performance of this class is not good, right? So there should be a response time, proper response time, and the transit time. This all together, you can say it is the performance of the network. Okay, so these two factors decides the performance of the network. And the second thing you must understand with respect to the performance is, the first one is number of users. See, whatever the network that you choose, there should be the support, the count of users that it supports matters a lot. Okay, and the next one, the type of transmission medium. See, whether you are using coaxial cable or optic fiber or radio waves, whatever the transmission medium that you use, that also decides the performance of the network. And the third one, the capabilities of connected hardware. The hardware connection, that also accountability for the performance of a network. And the last one is efficiency of the software. This four factor also decides the performance of a network. The last one, performance can also be evaluated using throughput and the delay. So the output of the network and also delay that happens in the network, these two factors also decides the performance of the network. So altogether, performance based can be measured in several ways. That is with respect to transit time and the response time. And the second thing is the performance of the network. Okay. Performance of a network depends on the number of users that it supports, the type of transmission medium that it follow, and capability of the connected hardware, and the last one is efficiency of the software. These four also decides the performance of the network. And the last one, the performance also depends on the throughput and the delay of the network. So throughput, to say the network performance of a network is good if the throughput is more and delay is less. Okay, this is all about the performance
Ma'am, what is
criteria.
throughput?
Throughput.
Ma'am?
See, throughput is, see, yeah, can you hear me? Yes?
Yes, ma'am. Yes, ma'am.
Am I audible?
Yes,
Huh.
ma'am.
See, throughput is, yeah. See, throughput is number of number of data packets that can be sent per unit of time. Okay, if I consider 1 millisecond, then how many data packets can be sent over the network? That we call it as a throughput. Is that clear?
Yes, ma'am. Thank you.
Is that clear to you?
Yes, ma'am. Yes, ma'am.
Yeah. And delay, yeah, delay is nothing but, see, if you're supposed to receive a data with now the time is 9:33, okay? So when I send a data over the network, it should reach uh, consider at 9:34. But if it is not reaching within that time slot, then I can say there is a delay in the network because you're not getting the intended data within a stipulated time. So that we call it as a delay in the network. Okay. So always delay should be less in the network and throughput should be more with respect to the network. So these are the things that comes under performance criteria. Okay. So next criteria is reliability. So what is reliability? A general definition for reliable. Hmm?
which
Yes.
in which we can depend on.
Yeah, okay. See, correct, good. See in day-to-day life, we do shopping, right? So there are many e-commerce platform where we shop for many things, right? So we rely on those apps because their service is good. Whenever we face certain problems, they'll I mean some people will be there from their end to serve us, right? So that we can call as reliability. Okay. Now with respect to network, reliability is what? See, whenever there is a network failure, so it should be recovered very soon. Okay, so that support we can call it as a reliability. So along with the accuracy of data delivery, the reliability plays a very important role with respect to the network. Say, I can take the example of BSNL network, okay, and Airtel network. As we all know, at some point, I mean, at some places, we don't get BSNL network in Karnataka, right? So why is that so? Because the proper recovery method for that. So being a user, we need network all the time if we want to communicate with other friends over the internet or anything. So since Airtel is more, we consider being a user, I consider Airtel is more reliable than the BSNL network. Okay, so that is reliability. So this network reliability is measured by the frequency of failure, like how many times there is a failure of the network. Okay, so it should be the frequency of failure should be very less to consider a network is to be a good network. Okay, and the second point is time taken by a link to recover from a failure. See, if there is a failure, I mean, if there is, one second, let me consider the pen. Okay. See, the time taken by a link to recover from a failure. See, if there is a link failure, then it should be recovered at a faster rate. So then only you can rely on the network. And third point is the network robustness in a catastrophe. So in case the setup destroys, the network setup destroys, then how far it recovers. That also counts the reliability of the network. So reliability of a network measured based on frequency of the failure and time taken by a link to recover from a failure, and the third one is network's robustness in a catastrophe. Okay, these are the 3 points. And the third one is security. So security is very important thing when it comes to network, right? See, we store our personal details in cell phone, right? And consider our cell phone is connected to internet. So if proper security is not provided, then what happens? The Someone can hack your cell phone and get all your personal details, right? See, and also another example is I do what I have online banking. So if security is not provided properly over the network, then whatever transaction that I perform over the internet can be what what I mean, the transaction performed over the network can be known by the intruder if proper security is not provided, right? So security plays a very important role in the network. We choose only those networks which provides a proper security over the data. So this network security includes protecting data from unauthorized access and implementing policies and procedures for recovery from the breaches and the data losses. Okay, so we use online, or you can say we use social media, right? See, many a times we read in the newspaper that the data users' data uh, is leaked, right? So recently, with respect to Facebook, I guess, so many users' data they have leaked to other other organization for so and so reason. So wherein we can consider that Facebook is not secure to the extent which we are expecting, right? So in such cases, network security should be properly given. So these three criteria is very important with respect to network. One is performance, second one is reliability, and third one is security. This is all about network criteria. Any doubts till now? Yes?
No doubts.
Okay, then we'll move on to the next topic, that is physical structures. See, physical structure related to the network. The first thing we saw with respect to network is network criteria, right? The second topic under network, we are going to discuss about physical structures, where we will be discussing few network attributes, like what is the type of connection followed and what is topology, that we all discuss under this topic. The first network attribute is type of connection. See, as already discussed, the network is what? Two or more devices which are connected through links, right? The communication link will be provided between the devices in a network. That is what the network definition, right? So here, when there is a link between the devices, then only the data can be transferred between the devices, isn't it? That is what we discussed in the network definition. So here, the link that is provided between the devices is of two form. One is point to point and the second one is multi-point. So the types of connection that can be established between the devices in a network is of two types. One is point to point, second one is multi-point. Point to point connection, if you see this diagram, you can understand it better. This the first diagram, this one. This, what is given here? Two devices are there, right? This is one device and this is another device, right? Here between these two devices, a communication or the dedicated link is provided. So these two devices communicate with each other with the help of this dedicated link. Okay, and this is an example for point-to-point connection. And the example for, the real-time example for point-to-point connection is, see, we all watch TV, right? Yes. So how you change the channel with the help of remote, right? So changing the television channel by infrared remote control can be the example where the point-to-point connection happens. That is from remote to television. So this changing channel with the help of infrared remote control is a good example for this point-to-point connection. Okay, and the next step is multi-point. Multi-point connection is also called as multi-drop connection. This is also called as multi-drop connection, where you can see here in this diagram, two or more specific devices are connected to this single link. That means this single link is shared between the multiple devices. These are the two ways using which you can connect the devices. Okay, so next topic is network topology. This is the second attribute. One second. Yeah, this next is the network topology, where this is the second attribute of network. Okay, network topology is nothing but, or you can say network topology is the way in which a network is laid out physically. That means the arrangement of nodes as well as links, that we call it as a topology. I will repeat, the network topology is nothing but the way in which our network is laid out physically. What does it mean? How the devices are connected with the help of links, that we call it as a network topology. Okay, so or another way you can represent it as, it is a geometric representation of the relationship of all the links and the linking devices to one another, that we call it as a network topology. So there are four basic topology followed. One is mesh, second one is star, third one is bus topology, and the last one is ring topology. I will repeat again. The topology is the way in which the devices and the links are connected. That is represented, the representation of this we call it as network topology. I hope this is clear to everyone. Okay. See, you can see in this here the diagram. Consider these are all the nodes. Okay. And this is the link. See, the arrangement of nodes and the link, the way in which these link and the nodes are arranged is different compared to the next one, right? So this arrangement we call it as bus. If you arrange the links and the nodes in this way, then we call that as a star. And if the links and the nodes are connected in this format, then we call that as a ring. And the fourth one, if the links and the nodes are connected in this form, then we call it as a mesh. Okay. So totally you can see the arrangement of nodes and the links is the representation of nodes and the links over the network, we call it as a topology.